Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So it's a pretty easy problem for today. We are given an integer num rows, which I just changed to n. So we are given an integer n, and we need to return the first n rows of uh, Pascal's triangle. So if you don't know what is Pascal triangle, there is a very clear visual representation shown here. Okay, so if n equals to 5, this is what you need to return. So if you just don't know what exactly is Pascal triangle, so I will just explain you that quickly. So a Pascal triangle is nothing but it gives the powers of 11. Okay, so it also gives the binary coefficient. So what do I mean by this? First two rows of the Pascal, this is the first row, this is the second row. These first two rows are fixed, and this from the third row onwards, it is calculated by something like you add this 1 and 2, 1 and 1, you get 2, and first and last element of a row is always 1. Okay, you always start with 1, then you see the previous row, you just add these two elements, it will be 3. Add these two elements, it will be 3, and then again after you are done with this, you just write another 1. Okay, the starting and the ending must be with 1. Okay, this is the property of every row of the Pascal triangle. So again, for the next row, you can see 1, and you just add these two, it will be 4. You just add this 3 and 3, it will be 6. Just add this 3 and 4, it will be 4. 3 and 1, it will be 4. So these properties of Pascal triangle, there are actually various properties also for Pascal triangle. I will not go into much of the depth, but for just your interest, I'm telling you, each row of Pascal triangles gives the powers of 11. So this is nothing but 11 power 0. This is nothing but 11 to the power 1. 121 is nothing but 11 square, which is 121. 1331 is 11 cube. Okay, and whatever you are seeing here, 14641 is nothing but 11 to the power 4. So it gives powers of 11, and it also gives the binary coefficients. Okay, so if you know binomial expression, if you have studied binomial expressions, these are nothing but the binomial coefficient when expanded. Okay, so I will not get into much of the details. I will just tell you how to solve the problem. So as you know, the Pascal triangle, as I have told you, uh, this is for n equals to 1, it will give only this output, and you need to store these in a 2D array. Okay, this is one array, this is one array, this is one array. Okay, this is one array, and you need to store all of these into a 2D array and return your answer. So what do you think will be the answer when n equals to 1? So n equals to 1, the answer will be something like this. Okay, you have a 2D array which consists of only one. You only return the first row, and n equal to 2, answer will be something like uh, you have the first row is this and the second row is this. Okay, the first two rows you just return. This is the first row, this is the second row. For n equals to 3, what do you do? You do nothing but you start from, you return this, right? 1, the second row is the same, and the third row is nothing but 1 2 1. So what can you do for generating, let's say n can be up to 30, it is given in the question, n can be up to 30. So for generating the ith Pascal triangle, so first these two base cases you can write easily. These are the two base cases which you can easily write. Okay, n equal to 1 and n equal to 2. And after writing the base cases, how will you determine the ith one? So what you can do, you can go to the I minus 1th. For the ith case, you can go to the I minus 1th, and let's say I minus 1 is something like 3 3 1 3 3 1. This vector you are having in I minus 1. So you start from the first index and go to the last index, just before the last index, and you just keep summing them up. So what I and I plus 1, you just keep summing this. So you get 4, you will get 6, you will get 4, and just in the beginning and at the end you add a 1 1, and after you have stored this, you just push back this into the answer. Okay, you just push back this into your answer. So this is how you can calculate the ith row from the I minus 1th row, and that is all. You just need to return answer. So how exactly you are doing this, we will just have a look quickly. So initially, we will have a vector of vector. Okay, we will have a simple vector of vector answer, And for if n equals to 1, at first we will just push back. What we are going to push back is a simple vector which consists only of 1. Okay. And if n equals to 1, we will just return answer, because that's what we have in the answer right now, only one vector of 1. And now for the next operation, we simply push back another vector which is nothing but 1 comma 1. And if n equals to 2, I will simply return answer. Okay, because now you know that this answer is having something like this. Okay, something like for n equal to 2. Now for every other, these are the two base cases. For every other element we will do something. Okay, for every other element we will do something. So what we will do, how many number of times more we need to do? Now see, n has decreased by 2. So n minus 2 times I need to do. Okay, so I will just have a loop. So if you already know this very easily, so if you have, let's say, x equals to 5 and you do while x minus minus, you are just iterating 5 times. Okay, so after 2 times are already, at first we needed to iterate n times, but for the first 2 rows we have taken care of in the base cases. So now we need to iterate n minus 2 times. So I set n to n minus 2 and I just do while n minus minus. What do I get? What do I exactly get? I will have a vector, let's say last. Okay, that is given by nothing but answer dot back. Okay, so what does answer dot back give me? So if my answer has something like, let's say, uh, this is one element, this is 1 comma 1, this is 1 2 1, this is 1 3 3 1, and let's say my answer is now this. Okay, and I want to find the next element in my answer. So that's, let's say, that is the ith element, and so I told you that I will find the I minus 1. So this is now the current last element. So answer dot back will give you this last element. Okay, and which you need to just sum up, okay. So I just take the last element from here, and I just go through them. What is from the starting from the first index to last dot size minus 1. Okay, so I just go to the second last element. I just go till the second last element. I'm iterating to the last one, and every time I will push back into some vector. So let me have another vector v which represents the ith row. Okay, so this represents the ith row. So initially every row starts with 1. So I will just push back a simple 1 here, since every row simply starts with 1. And every time I will just push back the sum of last I plus last I plus 1. So I hope you easily understand this. What do I mean by this? Last. So we are iterating through this last, and last is nothing but this in this case. Okay, and this is the ith element and this is the I plus 1th element. So I'm just adding up both of them. So what do I get? The first one, I and I plus 1, if I add, I will get 4, then 6, then 4. Okay, again. So 4 6 4 is the thing which I need to push. I just keep pushing, and at the end I just simply push another 1 because it starts with 1 and also it ends with 1. And so I just pushed it 1 and I just pushed answer dot push back. Okay, so answer dot uh, push back this v. I will just push this v back and I just return answer. It's as simple as that. There is no complication at all in this problem. You just need to implement it. So yeah, that's all. Let's try to run and check if we have done some error or not while coding. So yeah, see, we have the accepted case. If we try to submit it, I guess we will do quite well there also. So yeah, see, we do have the 100% runtime complexity, but we needed to return this 2D vector anyways. So I don't know why the memory is less, but yeah, it varies. It varies a lot, but you see the runtime is 100%. So yeah, that's all. That's all for this problem. I would say it was a pretty simple problem. If you know about Pascal triangle, definitely you should implement this on your own. So yeah, that's all for this video, and I hope your day also goes as easy as the problem. Thank you so much.